Now, Hooke's law. Okay, so let's state down the Hooke's law first. The stress is proportional. The stress is proportional to the strain within the elastic limit. Not within the elastic limit, within the proportionality limit. Within the proportionality limit. You understand why it is not elastic limit but proportional limit, right?
Yes, sir.
Okay, good then. Proportional limit. Because it is proportional only within this limit, but within the elastic limit, now we can see now here, let's say this is the graph. Okay, so something like this. So this is the elastic limit, and this proportionality limit. This is the elastic limit. So in this gap, it is not proportional, no, it's the curve, is some curve, like not straight line, right?
Yes, sir. Yes,
okay, so let's write. So stress is, we know that is the symbol sigma is proportional to strain. Okay.
Yes, sir.
So stress, we know that is force over area is proportional to strain is extension over initial length. Okay, so let's say the length of this is another color. Length of this is L. So L is the length. Okay, and this cross-sectional area, let's say that is capital A. Okay, and then we subject to a force F, so that it will attain extension E. Okay, so let's say that when applying a force, this one will have extension E. Now F over A is proportional to E over L. So here now I can write F over A is equals to, we put proportional limit capital E, or we can use capital Y. In some people use capital E, some people use capital Y, and because it is called Young's modulus or elastic modulus, either one of the term is correct. So E over L. So this is the formula that we have obtained from the Hooke's law. From the Hooke's law, okay?
Okay.
So yeah, let's box it. Okay. So here, let's say what is capital Y. So capital Y is Young's modulus. Young's modulus, or we could say that is the elastic modulus. Elastic modulus. Let's say what is the unit of Young's modulus? Can you tell me the unit of Young's modulus?
Probably like something like Pascal.
Yeah, because this side has the unit of pressure, and this side has no unit, so this has a unit of pressure, no? So newtons per meter squared. Okay. Okay, so it also has the dimension pressure. So Y dimensions is ml minus 1 T minus 2. Okay.
Yes.
Good. Okay, so here you can note down this note. If I consider this material, I can write here the this thing. Now cross-sectional area is a constant, L is a constant, Young modulus is a constant for the given material. So I can write F equals Y over AL times E. So let's take, so and then I can write F equals, this whole term is a constant. So I take that is a constant K. So F equals KE. So here K is called spring constant. K, spring constant. Spring
Yes,
constant. So in oscillations, you may have studied this formula, no? F equals Kx. So this formula is derived from using the Hooke's law. Okay, so here K is spring constant, and what is the unit of K?
Spring constant. You need to go. Spring constant. Newton. Is it Newton?
Newton per meter. The graph mark here. Okay. So this is strain and this stress. Okay, and then we know the graph, how the graph is, right? So it will like straight line will be something like this. Okay. Okay. So now within this is the proportional to the limit. Okay, that's bad. Okay, so within this, we can within the proportional limit, we know stress is proportional to strain. So if I consider the gradient of this graph, what will I get? What is the gradient of this graph?
Probably strain.
No.
Strain energy. I remember.
Okay, consider this from here. So here we can write here sigma equals to y times E, no? E over L is this capital epsilon, no? Right?
Yes,
so this is like y equals mx. So this is the y-axis, this x-axis. So the gradient is, what is the gradient?
Young's modulus.
Young's modulus. So the gradient is Young's modulus. I had to write a capital Y there because it's a name. Young's modulus. Okay. So the gradient is Young's modulus. Okay. So we write down F equals KE, where K equals Y over AL. Therefore, the K depends on the spring constant. The spring constant depends on what? There are three factors, no? One is Young's modulus or elastic modulus. And the other one is cross-sectional area. Cross-sectional area.
Mm,
And then third, the length, no?
yes, sir.
Length. So Hooke's law is simple. The stress is, I have to stress is proportional to strain. Let's say stress is proportional to strain within the proportional limit. Okay.
Yes, sir.
Okay, so it is very easy. Good. Yeah, and then we have to talk about the energy stored.